Welcome to episode 8. And in today's episode, we will talk about forms of hazardous energy found in the Lockout Tagout process, also known as the control of hazardous energy. Today's podcast is brought to you by the Occupational Safety Leadership Podcast. My name is Dr. David Ayers, and let's get started. So, forms of hazardous energy, they come in all kinds of shapes and sizes and sources and all that. We typically only think about electrical power when we think about energized states. And let's look at a couple of definitions here before we really get into the sources. So when we talk about how something is energized, it's connected to any energy source or containing residual or stored energy. It's also important to know that multiple energy sources can be found on equipment. Once again, we think about power only, but it's not uncommon to have power, clean, dry air. You could have nitrogen, depending on the process. So it can have multiple forms of hazardous energy. So let's go through a few of them. We have electrical, mechanical, thermal, pneumatic, chemical, both in the liquid and gas state, hydraulic, steam, and then the catch-all category of other. Sometimes things just don't fall in the nice, neat categories in life. The first one, electrical. So when you think about your everyday plug at your industrial outlet, you can also have something that's hardwired back to a electrical panel. But typically, any form of equipment out there is going to be hardwired back to a electrical disconnect, which is located really close to the source of the equipment, and then that, of course, in turn will then go back over to your power panel, breaker system, and all that stuff. Then let's go on to the next one here. Look at mechanical. So when we think about mechanical, gears and sprockets, pulley motors, belt conveyors, those kinds of stuff, then you can see from the picture on the top here. So think about a gear and a sprocket, something that's going to have some power behind it then. So we know we have to go back and control this energy because not only do we have to control this energy to take care of the maintenance, but we also know that typically we have to take a guard off of something when it comes to these types of things. And when we look at the bottom one, we look at a belt conveyor at a warehouse facility. I wish I could go back and talk to them and know what that green tape is on there. Is that where a person's standing, or does that symbolize something else? So let's go on to the next form of hazardous energy. We look at thermal. So in this picture here, we have a couple of maintenance guys who are working over at a foundry. So when we think about thermal, we mostly think about hot surfaces, but they can also be from cold surfaces then. Chemical reactions will cause thermal energy, typically on the warm side, but they can also happen on the cold side too. One thing to remember with thermal energy is that obviously it's going to take time for something to heat up or to cool down, depending on what the thermal energy is, so that you can go back and do that maintenance and servicing and figure out what's wrong. So that is something that will have to be factored in to when you go to do the lockout tagout. If you estimate it's going to take an hour for this thing to cool down, that's something that you have to factor in when you do this, so that you have that realistic expectation when working with others about how long a job will take. We'll go on to the next one here. Pneumatic. So this is typically found in the form of compressed air over at a industrial facility. Sometimes the compressed air is also dried, so they may dry it to a -40 dew point. But it's not also uncommon to find compressed gases in more of the high-tech manufacturing out there, because that nitrogen is not introducing any form of oxygen, any form of water. It does a really good job of driving all the internal valves and everything. So that is something that can be found in the more high-tech environments out there. Pneumatic energy. With this, you will also have to go back and bleed off that trapped energy. So you can go back and shut down the compressor as seen here, but on the inside it's still there, it's still trapped, so it would have to be bled off to make sure that you can go back and use it safely. Let's look at chemicals. So when we look at these, they're both in the liquid and the gas state. When we think about your liquids found in industrial processes, on the acid side, we have hydrochloric acid, sulfuric acid. All those are pretty large scale acids found out there. Base side, we have sodium hydroxide and ammonia. When we think about gases, carbon dioxide, chlorine. You can also think about nitrogen too. So nitrogen can not only be a like pneumatic, but it can also be chemical. So you could have multiple forms of energy. These are very common over at industrial plants. So not only do you have to bleed off anything that's trapped, if you have trapped hydrochloric acid, not only do you have to worry about the pressure that's involved, but you also have to worry about the hydrochloric acid getting on human skin or anything else. But it depends on what form of maintenance is really going on these processes. We will go on to the next slide here. We look at hydraulics then. So basically hydraulics are just confined liquids under pressure. So the only picture I could really find was a forklift for this. Forklifts do a great job of being the workhorse of the industrial settings. So it will take your load from point A to point B. So you can see where hydraulics are going to help you to put the forks underneath and raise that load up so that you can travel from point A to point B. If you have to go back and do maintenance on the forklift, you may have to go back and look at how do I make sure that if I have to, or not have to, or if it even happens by accident, that the hydraulics are going to stay in place. And that's why typically a load is always dropped. You're going to put some kind of bracing under it, because if the hydraulics are let go, not only do you have all that pressure involved too, but whatever was elevated will now be coming down as quick as possible to the earth. And that's hydraulics. We'll go on to the next one here. Let's look at steam. So steam is becoming less and less common out there as we kind of look at switching over from the old way of doing things, where there would be like at a facility a boiler, and of course the boiler is pushing out the steam, and the steam is doing a lot of the work, is doing a lot of the heating. But one thing that steam is very good for is to go back and look at heating up of chemical processes. So it's not going to obviously have a spark and a flame and all that kind of stuff. So it does a really good job of if anything's flammable, really kind of getting that heated up in a very, very safe state then. So and it's used in the heating and the HVAC systems out there. Steam, when it's trapped, of course, will not only have to cool down because it's hot, it's also trapped inside of there too. So this is one of those ones that falls under multiple chemicals, and once again we have to really go back and drain or bleed off anything that's trapped in these steam lines when we go back to do maintenance. And then finally, the catch-all. When you think about just anything else, something that you do have out in industry are going to be springs. You know, springs do a great job of coiling and uncoiling, depending upon the work they're supposed to do. You're going to have a lot of potential energy if you have a coiled up spring and you're trying to perform maintenance on something and that spring comes loose. So it's a lot of potential and stored energy that'll be shooting out at you. When we think about gravitational, conveyors going on different levels, if you stop a conveyor as it's taking up a heavy package, it probably will start to go backwards. So not only have you not stopped the conveyor to do the maintenance or whatever the activity is, but now that load is now coming downhill by gravity then. So you can introduce other hazards that you don't intend to introduce when trying to perform maintenance. And that wraps up episode 8, Lockout Tagout and the Form of Hazardous Energy. I'd like to thank the Occupational Safety Leadership Podcast for helping to sponsor this. Also, Applied Safety Management. My name is Dr. David Ayers. Have a safe day.